Hello, everyone. Today we're going to be talking a little bit about the moment of a factor about a specified axis or a scalar analysis. So basically what this is talking about is that this is an extension of what we have learned in 2D space, but now we're going to apply it to a 3D space. So it is important to know that if a force is parallel to an axis, that force will not produce any moment about that axis, and that if a force intersects an axis, that force will not produce any moment about that axis. So basically what it's saying is that if it is parallel to that axis, so in this figure, as you can see, we have this, what it looks to be as a vertical axis, and we could see that this vertical axis is parallel to this force that here it's to be as force P. So that force P will not produce any moment about that axis. Now, if that force also intersects an axis, like in this figure right here, that force will not produce any moment about that axis as well. Now, when it comes to moment of a couple, when there is a moment produced by two parallel forces, a distance d apart. So what this means is, as you can see, we have a force on this side going upwards, and then the other force is going downwards. So what we have here in this image is we have this distance of d. But if we were to take the moment about the center of the steering wheel, we know that each distance is equal to d over 2, since it's half of that. Since we know that the whole distance is equal to d, but we're taking it about that point, we know that the distance is d over 2. So if we were to write that out, we know we would write out our sign convention that our moment about that point, which here we'll call it O, is equal to, right here, this force on this side is creating a counterclockwise moment, which is positive, and this force right here is also creating that counterclockwise moment, so they're both positive. So we would get a positive, the first force, going upwards, so the force times d over 2 plus another force times d over 2, which in other words is the same as the force times the distance. So that's why when you have a couple, the moment of that couple is going to be the same as one force times the distance. And we're going to be showing some examples of what I talked about in these sections 4.5 and 4.6 in the upcoming videos, where I will be doing multiple examples showing how this comes into play.